Welcome everybody to network design. So in today's lecture, we're going to be covering selecting technologies and devices for a campus network. Now, things that we need to consider when selecting technologies and devices, we need to know what the network will look like. And that's why we basically do the design of the topology. So we come up with the network topology, we build it, we check the connections that are going to be necessary, we check the devices that are going to be needed for us to implement the network. And then it's up to us to start selecting the technologies and the devices. Okay. You don't necessarily need to start selecting the devices first. I don't actually recommend you to do that because otherwise you may be spending too much on a device that you don't even need. All right. So how do you need? You actually need a 48 port switch instead of a 24. How do you actually select these type of devices based on the features that they have if you don't know how the connections are going to look like? Uh, so one more thing, we also need to know the capabilities of the network. Not something new to you guys. We can buy $100 switches. We can buy $1,000 switches. We can buy $100,000 switches. Okay. Now, what comes down to which one we're going to select is not only the budget constraints that we discussed on the first few weeks, but also the capabilities. Some switches they have fast Ethernet ports. Some switches they have gigabit Ethernet ports. Some switches nowadays they even have 10 gigabit Ethernet ports. And choosing which one is going to be the one needed is actually coming down to selecting the technologies. And how are we going to do that if we don't have the design? So we designed everything first. We make sure we understand the technologies that we will need, and then we are ready now to start selecting the technologies and the devices. Something else we need to consider is the guidelines for the hierarchical design, because that is also going to play a role when we are choosing switches, routers. Do we need a layer 3 switch? Do we need a layer 2 switch? Do we actually need to pay the premium for a layer 3 switch if that is only going to be an access switch? So we have to make these type of decisions. So that's why we need to understand the technologies that we are already implementing in our network design. When we are actually selecting technologies for a campus network design and we are following the hierarchical model that we already discussed, we need to develop a cabling plant design. We need to select the types of cabling and we need to select the data link layer technologies. That includes connections, the switches, and so on. And we also need to select the inter-networking devices, and that includes meetings with vendors. Not only we need to understand the capabilities of the switches, the routers that we are buying, we also need to understand what vendor is actually offering the best deal. And if there is a better deal, this better deal, will it offer the things that I'm including in my design? For example, if our design is using EIGRP as the major routing protocol, even though EIGRP is open standard nowadays, most of the vendors they don't implement all of the features available in EIGRP. So also when buying from different vendors, we need to consider that different vendors have different protocols, different vendors have different ways of implementing certain technologies. So before we actually buy and we meet with a vendor, we need to consider budget constraints, we need to consider the technologies that we're going to use, and so on. The cabling plant design considerations we need to take include the distances. All right, so where are the devices going to be located? Where are we going to be installing these devices? So if we have the access switches in one building and we need to wire them up to the distribution layer switches, which are located in a different building, We need to be aware of the distance from one building to the other. We need to be aware of how the cabling is going to be done, okay? And these sort of things. The types and the lengths of cables between the buildings, they play a huge role as well. Because certain cables, they are Cat 5, Cat 6, they support different types of bandwidth, okay? Within buildings, we need to consider the location of the closets, of the server racks, and so on. We need to consider the types and lengths of the cables. We need to consider the connectors of the cables and so on. Okay, so these are all the things we need to be aware. We do have different types of topologies. We do have a centralized versus a distributed cabling topology. And it all comes down to some of them have advantages, some of them have disadvantages. So let's discuss about these two types of cabling stuff, okay, and understand which one is gonna meet our needs. So in a centralized cabling scheme, it terminates most or all of the cable runs in one area of the design environment. A star topology is an example of a centralized system. In a distributed cabling scheme, we terminate cable runs through the design environment. An example includes ring, bus, tree topologies, and so on. Now, let's have a look at the topology because words may be harder to understand. So let's have a look at an example of a centralized, an example of a distributed cabling scheme. In a centralized cabling campus design, we have something like this. So all the connections from one origin, which could be in this example, building A, they will be originating in building A and they will be terminating in each one of the other buildings. All right, pretty straightforward. From this design, we can identify some key advantages. One advantage, if one connection to one of the buildings fails, okay, that is not going to affect the functionality of the other buildings, the other sites, for example. So, for example, if this link from building A to building D fails, let's give an example here. Someone cuts the wire, the cable. That is not going to affect the functionality of building B and building C connection to building A. All right, so this is one example of a centralized campus design. In the other example of a distributed campus cabling, we don't necessarily need to wire things up from one building to all the other buildings. We can take advantage of the connection from one building to another building that already exists. So for example, if I want to connect my building C to building A, I don't need to run a cable all the way from building C to building A. I can take advantage of the connection, the existing connection from building A to building B, and I can just connect building B to building C. Right? That would be one way of doing it. Now, with the distributed campus cabling, it may sound like a good idea if you have some let's say some budget constraints. And why? Because you actually have to use less cable in reality. Okay, especially if building B is already closer to building C, it is much more cost effective to take advantage of the existing connection from A to B and basically run a cable from B to C. Okay, so in terms of cost effectiveness, I would say that the distributed campus design would be a good way to go. Now, if these budget constraints are not that big of a deal, all right, because especially nowadays cables are so inexpensive. So you buy a couple few 100 meters of cable, it's just super cheap. Now, if budget constraints not something to worry about, and you're willing to spend a little bit more for better availability, because after all, the other design that we discussed, the centralized, has a little bit of a better availability compared to this one. Now, the types of media that we can have to make the connections. So we do have copper media options, and that includes the Ethernet cables that we are so used to. And these Ethernet cables, they can be shielded twisted pair cables, they can be unshielded twisted pair cables. We do have optical media options as well. And in terms of optical media, we have the single mode fiber SMF, we have multi mode fiber MMF. All right, so we have options as well for optical media. And of course, we also need to remember we have the wireless options nowadays. And I'll tell you that the way that wireless media is advancing is amazing. Like wireless technologies, they're getting faster and faster with time, more and more secure with more and more secure encryption algorithms and so on. So it's also an option for us. So if we're talking about wireless, probably 20 years ago, uh, people didn't actually want to implement wireless in certain designs because of the slow bandwidth uh, that wireless was capable of. Nowadays, with the latest generations of wireless technologies, 802.11ac, 802.11ax, the fact that wireless bandwidth may slow down the connections is not that big of a deal anymore. Okay, because of the newest standards we have. Now, let's discuss a little bit more about the medias and how we can actually select them and how we select the best one for our design. With the copper media, we do have advantages. All right. And what are the advantages? The copper media conducts electricity current very, very well. Okay. They don't rust because most of them they're made with copper, and copper doesn't react much like metal. So if we're talking about metal and how metal reacts with water and stuff like that, and it gets rusty and humidity plays a big role, that's not a big deal with copper media connections. Okay, so they conduct electricity pretty well. They do not rust. They can be drawn into thin wires. So it's the cable is very thin. All right. Now, the one of the biggest advantages of the copper media compared to fiber optics is that copper media is extremely easy to shape. You can bend it, okay, you can twist it, and it's extremely hard to break. So if you take an Ethernet cable and you actually try to break it, it's gonna take a huge effort from you. And one of the advantage of this is much easier to lay these cables pretty much everywhere. Okay, you want to punch a hole through the wall and you want to pass an Ethernet cable through, you can do it. Okay, it's the Ethernet cable is very easy to shape. You can twist it; it's not going to break it very easily, and so on. You can bend it into sharp corners if you want. Okay, even though it's not recommended to bend it too much, you can still bend it a little and pass it through the corners as well. So it's a huge advantage. And one more thing is that nowadays copper bead is just super inexpensive, so cheap. All right, you can buy like a 300-meter cable, Cat6 on the internet, and pay like $40 for it. Okay, $40 to $50, 300 meters. All right. Now, copper media, we have coaxial and twisted pair. When we say copper media, most of us immediately think about the twisted pair. And we forget that actually coaxial cables is another type. Okay, coaxial cables, they are also made up of copper media, and they are good for certain applications. Okay, coaxial is still used a lot in countries such as the United States, Canada. They still use this type of technology a lot. Coaxial cable has great advantages as well in terms of bandwidth, in terms of transmission, and so on. Here in Australia, it's not used that much. I think some people told me that in Sydney, still something that they use over there a little bit, but I don't see it being used much here in Australia. Twisted pair, just like I said, super cheap. We do have two options: shielded twisted pair and unshielded twisted pair. So if you remember from Introduction to Networks, shielded twisted pair, unshielded twisted pair, it all comes down to how resilient to electromagnetic interference they are. So with the unshielded twisted pair, we don't have an extra layer of protection against electromagnetic interference. With the shielded twisted pair, you pay a little bit more of a premium, but you get that extra layer, which just basically looks like an aluminum foil wrapped around the thin wires that we have inside the cable. And that basically provides an extra layer of protection against electromagnetic interference. Now, one thing to notice here, guys, is due to the fact that we have copper media and due to the way that things work, copper media is extremely susceptible to interference. Okay? Now, if you actually think about doing a cabling course in the future, you have to study how you can better position Ethernet cables and copper media cables. Because if you place them near electricity wires, there's actually a chance of having too much interference in the wire. So it's recommended to lay all the Ethernet cables as far away as possible to the electricity cables. So this is something to be aware of as well. Now, in terms of coaxial cable, what do we have? We have a solid copper conductor. It's surrounded by flexible plastic insulation, braided copper shielding, and outer jacket. So these are the components of an Ethernet coaxial cable. They all have pretty much the same building blocks. They will have a flexible insulation. They will have a copper shielding. They will have an outer jacket to protect the cable itself, and so on. They can be run without as many boosts from repeaters for longer distances between network nodes than either STP or UDP. So the standard coaxial cables, they have a better range than the Ethernet cables themselves. Nonetheless, it's no longer used, especially here in Australia. I just don't know why. It's still a good technology, but I don't know why it's being discontinued.
Question, Robert.
Yakovic?
How far away would you recommend to put the, like the twisted pair cables from the electricity cables?
So the twisted pairs, Kavish, there's actually a regulation that tells you exactly how many meters. Now, from the top of my head, I don't remember, but I would recommend, with my experience, I would recommend at least probably 2-3 meters. Now, I know it may not be possible sometimes, but yeah, I would recommend at least 2-3 meters away. Just in case, just in case. All right. Now, there is actually an official recommendation for people that actually do the cabling course, the certified cabler. I'm going to do some research on that and I'll give you the exact answer, Kavish, of what is actually recommended. All right?
Thank you.
No worries. But there's actually a number, guys. So, yeah, be aware of that as well. All right. Now, in terms of twisted pair cabling, a twisted pair consists of two copper conductors twisted together. If you ever cut an Ethernet cable, you know there are a few wires inside and they are twisted in pairs. And have you ever thought about why they actually do that? Why do they actually twist one of the wires on top of the other, and why do they actually do that? That is actually to reduce something called crosstalk. Crosstalk is the interference from one wire into another. So the engineers just basically came up with this twist between two pairs of wires, and the twist just basically reduces this crosstalk interference, which is the interference from one wire to the other. All right. Now, each conductor has plastic insulation, and we do have the two options, the shielded twisted pair and the unshielded twisted pair. Now, here in Australia, I think I've pretty much never seen the shielded twisted pair being used before for just standard applications such as home applications, small to medium-sized businesses, and so on. Now, the shielded twisted pair is more expensive and is recommended whenever we have a factory, for example, where we have big motors and big devices that cause electromagnetic interference. Shielded twisted pair is strongly recommended. Okay. Now, for standard applications such as home applications, small to medium sized businesses, unshielded twisted pair is more than enough. It will do the job, and that's it. Right? Now, the categories of cables. We do discuss a lot about the wireless standard and which one is the newest wireless standard, which one has the highest bandwidth, and so on and so forth. But we don't discuss much the categories of Ethernet cables. We do have different categories of Ethernet cables, guys. You may take many Ethernet cables. If you take an Ethernet cable which is 20 years old and you take one which is like brand new, if you have a look at them, maybe the 20 years old one will look a little bit older because it's going to be used compared to the new one. Now, in terms of to the naked eye, you won't be able to say which one is the newest category. Sometimes some of them they actually come written in the protective layer. They come written with the category of cable, but you can really tell by looking at the cable itself if it's a Cat 4 or it's a Cat 5 or if it's a Cat 5/6E or whatever. So what you basically need to do is you need to be aware that the category plays a big role in the bandwidth requirements. All right. So the old categories of cables, category 1, 2, 3, they were extremely low bandwidth compared to modern standards. In today's standards, everything which is lower than 100 megabits per second is considered to be slow. So nowadays, the category 5, 5E, they are basically the most recommended for home applications, small to medium-sized businesses, and so on. With the category 5, I think it's one of the most used ones nowadays, up to 100 megabits per second. All right. For most of the categories, guys, there is actually a range as well. So with all the Ethernet cables up to category 6, the recommended range is up to 100 meters. Okay, if you go with a cable which is longer than 100 meters, the signal degradation may be too high for you to actually get a usable signal in the other end of the cable. So it is recommended for all the Ethernet cables to be a maximum of 100 meters long. And you might be saying, oh, but I have no more option. I have to have an Ethernet connection and it has to be more than 100 meters. What can I do to, get around that? You can actually install a repeater. Okay, so every 100 meters, you put it in a repeater. And by the way, the hubs, they are used for that as well. So they basically use to boost the signal whenever we can have, whenever we need to have a length of more than 100 meters, we can go with a repeater or a hub. Or some people actually buy cheap switches to do that as well, because they will receive everything in one port and basically broadcast to the other port and so on. All right, cool. In terms of optical media, we do have two options. We have single mode fiber, multi-mode fiber. All right, these are the two options we have nowadays. We want to implement fiber optic connections. Why would we use fiber optic cabling instead of copper? Even nowadays, why would we go with fiber? Now, if you asked me this question probably 10 to 15 years ago, we did have Cat 5 5E, which was like the standards that we had for Ethernet at the time. They would go up to 100 or even 1 gigabit Ethernet, while the fiber optic cables at the time, they could provide up to 10 gigabit per second Ethernet. So if you're asking me this question 10, 15 years ago, or not only me, but all the network engineers at the time, they would tell you that whenever you want to have a bandwidth higher than 1 gigabit Ethernet, just go with the fiber because we don't have it available in Ethernet cables, right? Now, nowadays, this is not necessarily true because we do have Cat 6 and even Cat 7 nowadays. People are already talking about Cat 7. So we basically have 10 gigabits per second already in copper. All right. So I don't actually like to tell you that you want to go with more than 10 gigabits per second, you have to go with fiber because this is not necessarily true. All right. Now, fiber does have advantages still that you need to consider. One of them is that fiber relies onto optical communications. You actually have um, pulses of light instead of electromagnetic current, electricity. So that basically means that fiber is less susceptible to interference from electromagnetic sources. Okay, so you don't have enough room to put a cable that is not as close to the electric grid. No problem. You might want to go with fiber, and that is not going to be susceptible to the electromagnetic interference that the electric cables may cause uh, in your networking cable. All right. Other reasons include they are not susceptible to attenuation, which means we can have longer cables than the 100 meters that we have for Ethernet cables. It supports very high bandwidth. Not only it does support 10 gigabit per second bandwidth, but even higher. Okay? They're also good for long distances, and fiber costs less than copper. Now, that is actually not necessarily true. There is a break-even point where fiber will be more uh, cost-effective than Ethernet. It all comes down to the range, okay, the distance. So in certain applications, fiber will cost less. In certain applications, Ethernet, copper will cost less. It all depends. Okay, so that's why we need to check the distance, do the calculations, and so on. Now, in terms of the types of fiber connections we can have and the fiber cables that we can have, we do have multi-mode fiber and single mode fiber. With multi-mode fiber, we have a larger core diameter. We have beams of light that bounces off, collecting in multiple ways. It uses LED source. It is much, much cheaper than single mode because it uses LED. So LED is super cheap nowadays. And that's why multi-mode is super cheap compared to single mode. Now, with multi-mode, because we use inexpensive LEDs and because of the way that the light is transmitted bouncing off the cable, we have shorter distances in multi-mode cables compared to single mode cables. Okay? With single mode cables, we have a smaller core diameter. It's less bouncing around. It's a single focused beam of light. And this beam of light is usually done with lasers. And because laser technologies are more expensive than LED, single mode fiber is more expensive than LED multi-mode fiber connections. And they're good for very long distances. Now, ISP connections, guys. If you think about ISP connections, if I want to connect my point of presence, which is basically the place where I'm going to have all my routers and switches for my ISP, and I want to connect my ISP to another ISP in Sydney. That's like a 250 kilometers away. The only choice we would have available would be a single mode, okay, in terms of cost effectiveness, because that would be good for a few kilometers away, okay, a few hundreds of kilometers away. You can go with single mode fiber. Now, in terms of wireless media, pretty much the same. Every single one of the standards for wireless, they have different frequencies, they have different speeds, the bandwidth, and they basically are recommended for different ranges. So for the 802.11a, we had the first 5 gigahertz frequency wireless signals. They're good for up to 54 megabits per second. However, the range is just up to 30 meters. With the 802.11b, we have 24 gigahertz as well as the 802.11g. Okay, 802.11g is actually better suitable for high speed, higher bandwidth than the B standard, and it goes up to 38 meters compared to 35 of the B standard. We also have the 802.11n, which uses both frequencies, the 2.4 and the 5. All right, can use both of them. It is good for up to 300 megabits per second or 600 megabits per second on a dual link using both of the frequencies. It's good for up to 70 meters. And we also have the 802.11ac, which is 5 gigahertz up to gigabit speeds. All right. And it's good for up to 27 meters. And we also have the 802.11ax, which is the newest, better standard nowadays, which is also operates at both frequencies, so 2.4 and 5, and it goes up more than 1 gigabit per second speeds. All right, and the range is comparable to the one of the N standard. All right. Cabling guidelines. So at the access layer, we usually use a copper UTP rated category 5 or 6 at least. Okay. Nowadays, with 6 and 7 getting cheaper and cheaper, recommending already Cat 6, Cat 7 for the access layer connections as well. In special cases, we can use multi-mode fiber for bandwidth intensive applications or to install fiber along with the copper. Now, I need to tell you guys this because I get this question a lot. Okay, so how do I know if I need to use a fiber connection to my access layer? I'll give you one example. When you have a server room, okay? You guys read here, it says use multi-mode fiber for bandwidth intensive applications. Where do you expect to have bandwidth intensive applications? In a server room. All right. And that's why if you go to CIT, to our labs at CIT, we do have all the computers in the labs. They connect to the switch using Ethernet cables, right? So it's the category 5E. They go from the desktops all the way to the switch, to the access switch. And that access switch also has multi-mode fiber connections that goes all the way to the server room that we have in D207, I think. So that's where we have the multi-mode fiber connections whenever we have bandwidth intensive applications. So why do we have bandwidth intensive applications to the server room at CIT? Because you guys have to re-image the machines all the time. So all the time you have to retrieve the image from the server. So there's actually a lot of bandwidth requirement going to the server room and out of the server room to carry all these traffic that is associated to the images, associated to the operating systems, associated to big files, large files, and so on. At the distribution layer, what we usually do at the distribution layer. So at the distribution layer switches, we usually recommend multi-mode fiber if the distance allows, or single mode fiber if the distance is a few kilometers away. Okay? So multi-mode fiber, if it's less than probably a kilometer away, a few meters, few hundred meters, say 500 meters away, multi-mode fiber can still do the job. If it's more than that, single mode fiber is actually recommended. Now, unless unusual circumstances occur and cable cannot be run, the use of wireless can also be recommended. All right. Also another option that we have. Now, if we cannot do the multi-mode fiber or single mode fiber at the distribution layer, we can actually use a higher standard than the one used at the access layer. So let's say your access layer is all Cat 5e cables, so they can go up to 1 gigabit Ethernet. For the distribution layers, if you can't go with any of the fiber technologies, you can go with a standard, a an Ethernet standard which is with higher bandwidth than the ones that you have at the access layer. So it could be, for example, a Cat6, Cat6a up to 10 gigabits per second. That would be enough for your distribution layer. Now, in the LAN technologies, we have the 10 megabits per second Ethernet. I don't even have to mention that. It's obsolete. We still have the 100 megabits per second Ethernet still around. Okay, we still have network interface cards, the NICs, that are only capable of doing 100 megabits per second. But nowadays, the de facto standard is becoming at least the gigabit Ethernet networking adapters. And that basically means we're getting higher bandwidth in all of the links pretty much. We also do have the 10 gigabit per second Ethernet, even though they're not very used because the NICs are too expensive still for the 10 gigabits per second Ethernet. They are still becoming more and more popular as well as cost goes down. And one technology that we can rely on for higher bandwidth as well in terms of LAN technologies is the Ether channel link aggregation. Now, with the 802.3 standards, now if you remember the 802.3 standards, they're all the Ethernet standards. Okay, so we do have 10 megabits per second. They can be 10 base 5. So it's thick coaxial cable up to 500 meters. We have the 10 base 2, thin coaxial cable up to 185 meters. We have the 10 base T, the 10 broad 36, the 10 base F. They all serve for different purposes. Now the 10 base T, 2 pairs of category 3, and they can go up to 100 meters. They are all unshielded. We have the 3-channel of private Cat TV system, 3600 meters, which is the 10 broad 36. And we also have the 10 base F, which is basically 2 multi-mode optical fibers that still provide up to 10 megabits per second connections. With the 100 base, we have the 100 base T, which derives the 100 base X, the 100 base TX, FX. So with the 100 base TX, we have 2 pairs of category 5 or better unshielded twisted pair, and they go up to 100 meters. We have the 100 base FX, 2 multi-mode optical fibers that can run up to 2 kilometers away. We also have the 100 base T4, 4 pairs category 3 or better that can go up to 100 meters. And we also have the 100 base T2, 2 pairs of category 3 or better unshielded twisted pair cables are used, and they can go up to 100 meters. So if there's one thing in common with the unshielded twisted pair copper cables, is that most of them, they only go up to 100 meters. All right. Now we talk about the gigabit Ethernet, the revolutionary 1 gigabit Ethernet. It's the 1000 base X. From the 1000 base X, or all the types of cables that can support the 1 gigabit Ethernet, we have the 1000 base SX, which uses 2 multi-mode optical fibers. They are short-wave laser optics. They go up to 550 meters. We have the 1000 base LX, 2 multi-mode or single-mode optical fibers. They can go up to 550 meters if multi-mode, and up to 5000 meters using single-mode. We also have the 1000 base CX, 2 pairs of single twisted pair, shielded twisted pair, sorry, and they can go up to 25 meters. And we also have the 1000 base T, which is 4 pairs of category 5 unshielded twisted pair that goes up to 100 meters. With the 10 gigabit per second Ethernet, we have the 10G base with fiber cabling. So we do have the 10G base LX4, SR, LR, and ER. So they are multi-mode or single mode. They can go up to 300 meters or 10 kilometers using single mode. With the base SR, we have multi-mode optical that can go up to 300 meters. And with the single mode optical fibers in the LR standard, we have 10 kilometers, up to 10 kilometers away. And we do have the 10 G-Base ER that uses single mode optical fiber and that goes up to 40 kilometers. We also have the 10 gigabit per second Ethernet, which is pretty awesome standard for providing high-speed Ethernet connections. So we do have the 10G base copper, the G base CX4, the SFP Plus Direct, and the G base T. With the G base CX4, we do have the 10 gigabit per second at an awful cost of range, only 15 meters. With the SF Plus Direct, we have an awful range as well, just 10 meters. And the latest, very good standard for 10 gigabit per second Ethernet, the 10 gig base T, which can use UTP or STP cables up to 100 meters. With the Cisco Etherchannel technologies, it's a way that we can basically get around changing the cables whenever we want to have high bandwidth. We can basically bundle and combine different physical connections into one connection, providing a higher bandwidth. So in this example here, if we had two connections, two wire connections, each one operating at 400 megabits per second, we could combine them into a single Ether channel, providing twice the bandwidth that each one can provide. Now, into networking devices for campus networks, we have switches, routers, wireless access points, and wireless bridges. How do we select each one of them? We come down to a selection criteria. The number of ports is important because it comes down to how much we're going to spend buying certain switches and routers. Processing speed is also something else to consider. So some students actually asked me this question before. What is the difference between a switch that was built in 2010 with all 48 gigabit Ethernet ports compared to a switch which costs 10 times more that was produced nowadays, that is also gigabit port? What is actually the difference? Why am I actually paying much more for the newest one? It all comes down to processing speed as well. Okay? How fast the CPU can basically forward the frames, make routing decisions if it's a router, and so on and so forth. So processing speed, the speed of the CPU also plays a role when selecting routers and switches. The amount of memory as well plays a huge role when we are buying routers and switches, and the price that we pay for each one of them. Latency, and latency is associated to the processing speed as well. The throughput as well, how fast each one of the Ethernet ports are, or the fiber ports are, and so on. And the LAN and WAN technologies that they support. For example, some routers, they support VPN technologies, others don't. So do we actually need a router which is more expensive that will support VPN? Do we actually need VPN? So we need to ask ourselves all of this. And the media supported. So some switches, some routers, they only support Ethernet, copper cables, and stuff like that. So do we actually require to have fiber? Do we need to have fiber connections? So we're going to have to buy devices that support fiber connections as well. More selection criteria that we need to consider: the cost, ease of configuration. Some of them are easy to deploy, easy to configure. The MTBF, MTTR, if you remember when we talked about the availability, is associated with MTBF, MTTR. The minimum, the mean time between failures, the mean time between repairs. So we need to consider all of this as well. If they have hot swappable components, if they support redundant power supplies, the quality of the documentation, support, and training. And this is one of the most, the biggest reasons why nowadays people still go with Cisco devices, even though they pay a little bit more of a premium for Cisco devices, is the fact that Cisco has great documentation, great resources online, and it's simple to find information about their devices. This is a summary of everything we talked about today. So we talked about the logical design and how it is so complex and that right after we design the topology, we are then able to start making physical design decisions on what type of devices we need to buy, what type of connections we need to have, and what type of media we should select, and so on. We do have some review questions for you guys to have a look at. So try to think about these review questions and about the answers that you would give to some of these. Some of these will actually be in your day-to-day activities as a network engineer, because sometimes you will have to make decisions. And how you're going to make these decisions, you need to understand the things that we discussed in today's lecture.